Good morning, students. Please welcome to our online class. In AC motors C18 EE 503, and before starting our classes, my sincere thanks and courtesy to all authors for sharing valuable materials. What we have seen in previous class. Have you observed this machine? What is this? Whether it is a DC motor, synchronous motor or induction motor. Which one? Yes, it is 3-phase induction motor. Okay, the 3-phase induction motor, before going to real application, that is, it is before coupling to our application, mechanical coupling, we should require to know its some performance characteristics. Those are not available on the nameplate. For example, what you are observed in nameplate of any motor, maximum the company and voltage, current, power in HP or kilowatts, cooling type. So these are the power factors sometimes. But I want to know that what is the efficiency, what is the starting torque, what is the slip, what is the power factor of this machine with changing with load, full load and no load and off load, and what is the starting torque. This can be known before going to install our induction motor to real applications. We are going to conduct 2 main tests on a 3-phase induction motor. So before going to participate in the real game, before that we are going to warm up our body. So warm up exercise is required to win the goal. Similarly, I want to know that what is its efficiency. The efficiency varies based on what factors. If load is added, whether efficiency increased or decreased, at which it giving the maximum efficiency. What is the starting torque? What is the power factor at starting, at off load, at full load? This can be easily known by conducting no load test on 3-phase induction motor and black rotor test on a 3-phase induction motor. Based on these 2 tests, so we are going to write Jataka Chakra of induction motor, horoscope. So based on this horoscope, we can predict what is its efficiency at that moment, at that load, and what is its maximum torque. Everything we can predict based on the measuring the length. Okay, so that's why it is a very important to know as an electrical student how to draw a circle diagram. What is a circle diagram? It is a graphical method to analyze the performance of a 3-phase induction motors. What are the parameters? So it may be efficiency, at slip, power factor, torque, maximum output, etc., etc. Okay, the method here, this method aims at plotting the locus of input stator current, that is I1, for various values of slip. What is the slip? Slip is equal to no load synchronous speed minus rotor speed divided by ns. That means if the relative speed between the RMF and rotor speed, that indicates the slip speed. If S changes, how the input current taken from the supply, its a magnitude, its power factor angle changes. I want to know that. If I know this input current based on slip, I can draw the one diagram. I am going to get it, that is the circle diagram. Okay. So, how to draw the circle diagram? Why we have to draw the circle diagram? Already we have seen in previous classes. So, as the applied voltage, that is the input voltage V1 is drawn vertically, all vertical represent the power components of currents. Okay. So, vertical distances generally, so we can take for example no load current, that is equal to this A, that is from 0 to A, that is a no load current at an angle of cos phi 0. If you write the vertical from the A to Q in previous figure, so we are going to get the I0 cos phi 0 represents the no load input which supplies core losses, the mechanical losses and stator copper losses, as you already seen in previous classes. Okay. So, now let us recall this one. Okay. Now, you can see this is what we have seen in previous classes. Okay. So, all vertical we taken as a OX is a reference axis, X axis, and OY is the vertical axis. In that case, we taken as a voltage as this value, vertical axis. Now, you can see based on the no load test and this. So, now take it this one. So, we know that from no load test, so we are going to get it. What is that one? So, from ammeter I naught, voltmeter V naught, from wattmeters we are going to the W naught. Okay. From block rotor test, we are going to get from ammeter I am going to let rated current ISC and VSC and WSC. These readings are measured from no load test and block rotor test. And another test also we conducted to know the R1, that is equal to, so rotor resistance, the stator resistance method, that is a VI method. Okay. These three tests are essential for knowing performance of 3-phase induction motor with the help of circle diagram. Okay. So, based on this one, from no load test we have calculated. So, from no load test we are going to get it, what is the I0 at an angle of phi 0, we calculated from this one. And at the same time here I am going to get it ISC at angle of phi SC, but I required instead of short circuit current with reduced voltage. This is based on the reduced voltage, only fraction 10 to 20% of the voltage, but I want the voltage based on the rated voltage. So, that is equal, I can write it ISN normal voltage, then I am going to get it phi SC. So, this is the one thing I required, I am going to require this thing. How to convert this value? Already we have seen in previous classes. Okay. So, how we are going to calculate that one? So, already you know that what is the formula, that purpose simply ISN, okay, that is the normal voltage, we are going to get it ISC into, that is equal to, so voltage, V normal voltage divided by VSC, that is short circuit voltage whole square. Okay, these are the already we have seen in previous class. So this is the value. Okay, so based on these values, this value, and based on this value, I am going to draw the diagram. So what is happened here? I know that I0 at an angle of phi 0 and ISN at angle of phi SC. Okay, so this based on this one, I can take this is the vector diagram. You can take this is a vertical axis, we taken as a y axis, and this is the horizontal axis, we taken as a x axis. So here x axis is a reference axis, we taken the reference. Okay, reference axis. Now y axis we taken the all voltages vertically. Now based on this I0 at an angle of phi, so we taken the V is a reference. From this one we are going to write it. Okay, so now here in this case all verticals are taken as a reference. From here phi 0, it may be for example phi 0 78 degrees. Then I can take from this one. Okay, then what is the phi 0? So dear students, you know that, so whatever this current values convert into scale values. Okay, for example, you take the 1 centimeter is equal to, here you can do the, for example, 2 amperes, that is the current scale. Okay, similarly converted power scale also. Okay, if first we taken the what is the I0, based on this one magnitude I am going to get, for example, this is the I0. Okay, so this is the phi 0, suppose 578. I can take this point is the taken as a point. Okay, so this from A point to I can write it here, this is the angle. Now from this one I can write it phi SC. Phi SC, for example, this angle is 78, this may be 68. So that means from this one you are going to write it 68. So I am going to write it, so another this one. What is the angle? So now you can take this is equal to B, you can take it as a B. Okay, now this is equal to ISN magnitude at an angle of phi SC. This is a I0, the magnitude. Okay, so A and B 2 points we know. Now third step, so you are going to know that join the A and B. So 2 lines, the third step you join the this A and B. Okay, after the next stage, so draw the one line parallel to the OA reference axis, x axis from A. Okay, so what is happened? So this we can write it, this is known as the fixed losses, Okay, so this indicates vertical component is indicates the fixed losses. Now, so what has happened? So you can write it, this is up to, we are going to write it up to, you can this is the D. Okay, dear student, don't bother about the numbers A, B, C, D. You can write it anything arbitrarily. Now here I am going to write it, this is the D. Now so A, B is connected, I can write it, this is the output line. So I can write it, AB is the output line. Now bisect the AB line by using the compass. Okay, we are going to get it compass, then we are going to get it this value in this one, for example this one. Okay, so here it is cutting this one, so we can say this is known as a C center. Okay, so bisected in this case, and A and B should be on the semicircle. Take the AC as a radius and draw the one line. What do you mean? That can you write it the one semicircle. Okay, now you draw the one semicircle. This is a one semicircle. Okay, so we draw from the here what is the AC is equal, right? Then this is equal D. So don't write here, write the D. Now AD is the diameter and AC is the radius of the circle. Now up to we are clear. Now next step what to do? So simply drop the one line. So you can take the another color. Okay, we take the blue color and so draw the one line from this place to this place up to x axis. Okay, now what is happened? So this is a mix here, this is here, and you are going to this one. Okay, now what is happened here? This is the B point. Okay, and this is the, we can say this is equal F point and this is equal G point. F, okay, you can take it this one. This is equal F, this is 1. Now what is happened? BG is equal to, that is known as the total loss, total power to the input. That is called whatever the BG, that equal to the nearly supplied total losses. Okay, so under block rotor conditions at rated voltage, the power input is equal BG. Okay, so this rotor is the blocked one, it is unable to rotate. Whatever the input is given to the motor, that is dissipated in the form of heat energy, that is called BG. So the BG is the sum of the core losses and copper losses. Okay, now here FG is the fixed losses, that we can say the core losses, and BF is the copper losses. Now BF is equal to this copper losses. So BF can be total copper losses, that is equal to rotor copper loss plus stator copper loss. Stator copper loss and rotor copper losses. I want to separate these two losses. So that purpose I know the one point is a location, how to separate it one. So here what is happened? I am going to separate the, where is the, how many rotor losses, how many stator losses, copper losses. Okay, that purpose I require the one point in between the BF. So I require the one, that point is equal to, I can write the E. Okay, how to locate the point E? So in previous classes we have seen that so there is a two options. What are the two options for location of E? So in case of squirrel cage rotor, squirrel cage and slip ring, there is a two options, slip ring rotor. In squirrel cage what we are going to do? In squirrel cage, so you know that what is happened? So under block rotor test, input to the motor approximately equal to the total copper losses. Okay, so here what will happen? So anyway mechanical losses is a very neglected. So mechanical loss is 0 because rotor is blocked, and iron losses are very low as compared to the copper losses. So at that condition, whatever the wattmeter shows WSC, that is equal to the total copper losses, total copper loss. Okay, this total copper losses. Now this total copper losses, now what is the stator copper losses? So we know that the W, this is a wattmeter reading, this is a wattmeter reading. Then I know the stator current, I know the stator resistance. Stator resistance conducted by VI method. I know the R1. So what is happened? The stator. So I conducted the I injected the some current. I measured the some voltage. From this one, I am going to get it R1. At the same time, I know the I1. Then I can calculate what is the stator copper losses. The stator copper losses is equal copper loss is equal what is the formula? So that is called 3 phase, that is called 3 into I square R. Okay. Now it is a stator R1, this at the short circuit condition, what is the current? ISC. So this is the values. Now I know the stator copper losses, I know the total copper losses, total copper loss from WSC. Okay, I want the total losses. Now what is this one? Total copper loss is equal to stator, okay, stator copper loss plus rotor copper loss. Total copper loss, we know that is a WSC, and stator copper losses, that is called 3 into I square SC into R1. So I know this is I require the rotor copper loss only. So I know this value, I know this value, I can easily calculate the what is the rotor copper losses. So based on the thing, I am going to rotor copper loss by stator copper loss, I can proportionate, I can get the divide this line into this ratio. So most of the problems we are assuming is equal. So this is equal to this equal. If not, so you can calculate such a way that it is clear. Now this is the location of point E in case of squirrel cage induction motor. So sir, okay, it's okay. Now coming to the slip ring rotor, there is a winding in rotor also, and so how to find that thing? So that purpose, so I am going to, and this second case, so here I am going to find the location. Okay, that purpose I will take the another color. Let us take this one. Okay, so what is happen here? Same, that is the under block rotor test. What are the input approximately equal to the copper losses? Okay, so copper loss in the form of heat energy. Now what is known? So I know that, so from stator and rotor, I know the what is the R1 from VI method, I know the R2 from the VI method, because both are wound winding. At the same time, I can find that what is the I1, I can know that what is the rotor I2. So both values I can know. So here based on this one, I can easily calculate so rotor copper loss by stator copper loss. Okay, rotor copper loss by stator copper loss. Okay, that is equal to I square I2 whole square R2 by I1 whole square R1. Okay, here what is happen? So I can write it I2 by I1 whole square into R2 by R1. So whereas the I2 by I1 is equal to, we know that transformation ratio K is equal to, that is a E2 by E1 and N2 by N1 and I1 by I2. So from these values I can calculate what is the this value. Okay, so that I can write it R2 by, so I can write the K square R1. So if I this known and this known, I can know the what is the ratio of this one. So I am going to get it, it is the ratio, this value to this value. So proportionately I can divide this value from how the based on the proportionate I can divide the, this is a rotor copper loss, this is a stator copper loss. Okay, dear students, already we have seen this previous classes. Okay, I am repeating this one for easy to understand. Okay, so this is a one method, simple method to find out the location of E in copper losses. Okay, after that, so what next? So I know this one. Let us go to our diagram. So now I can join the E point. So whether I can join the E point here, then it's over. So now we found rotor copper losses, stator copper losses, fixed losses, and this is a AE is a torque line and AB is a output line. Okay, so these all things we know. Now I want to know that rated current. That's a I2 I require the what is the current. So that purpose I require the some operating point is required. So how we are going to find the operating point? So first measure the what is the length of BG here. So here I am going to get, so BG, this is called B, and G, find the length. For example, how many centimeters? So based on centimeters, you suppose 4 centimeters. Now this is the power, BG total power. That is the rotor copper losses, stator copper losses, fixed losses. Now you know the output of the motor. Output of the motor is given on the nameplates. For example, 5 HP motor, this is the output rating, convert into watts. So how we are going to convert? That is equal to 1 HP is equal to 745.5 watts. So based on this one, you are going to get it output in watts. Okay, this is the output. Now based on this one, so I am also found the scale. So here what is the scale? So in previous cases, power scale. So WSA, already we know that power scale. Okay, so how we are going to find that power scale? Now the power scale already we have seen. So that is called WSN. That is called at normal voltage applied to the motor at block rotor test. Then so what is the value? So similarly, so that is equal to WSC, the wattmeter reading, into normal voltage divided by short circuit voltage. That is equal to, we are going to get it whole square. So based on this one, we are going to the what is the power consumed if the rated voltage applied to the motor under block rotor test. So dear student, don't give the rated voltage during the block rotor test, motor will spoil. Here we are converted, we are given the rated current with fraction of voltage only under block rotor test. From this readings, I converted into, if I given the, suppose 20% of the rated voltage is given to this one, I am going to get this much of the power. If I given the rated voltage, then what is the power of the motor? So I know this value. Okay, just you do the problem, don't practical do it. Okay, so that is a WSN. Then you convert the power scale. So this is the total power. So from this one, you are going to calculate what is the power scale. So power scale is equal to, you are going to what is the length, you are calculated, that is the from G to, so total length, you know it. Okay, so from this one, so you are going to get some kilowatts. Okay, then you are going to get 1 centimeter is equal to some kilowatts, some x kilowatts. So that is the power scale. Okay, so from this power scale, you are going to use in output equation, where so here I am going to get it, whatever the rated value is given here, 5 HP motor. Okay, so whatever the 5 HP motor, just convert it. So what is the 5 HP motor? You are going to get 5 HP. So convert it into 5 into 745.5. Okay, that is going to 3728.5 watts. But from this one, I know the scale. What is the scale? From 1 centimeters, I am going to get that. So 839.5 watts. For example, you take it, whatever the value you are calculated. So that is 1 centimeter is equal, instead of x, I assumed this is the 839.5 watts. Now, what is the length of this one in terms of, this is the total power. Now, convert length, how many centimeters? Then that is the length is equal 3728 total watts divided by 839.5. So we are going to nearly 4.44 centimeters. Okay, this is a length, approximately they are taken the length. Okay, so if you know the length, what is the length? That is called BL. So what is the BL? You can see here. So this is a B. Okay, from B, so extend the line this up to this one. Length, what is the distance? 4.44. Okay, this is another step, dear students. So this is another step to know the point P, okay, on a semicircle. So that purpose, so you are going to do this some simple calculations. Okay, now join this from L and parallel with the AB and join, this is the parallel to this one, you are going to write it. Then here is the one point. Now, so join the from O, you represent, this is the P. This is the represent, this is the P. Now, so from P, join the from O to, so you are going to get, okay, from this to you join up to P. So this P line, the line which is drawn from the O to P, this is a full load current. We can write the full load current. We can write the I2. Okay, from P2, so draw the one vertical line on the up to reference axis. So in parallel with the V axis. So here what is happened? So this from P to this line, I can represent. What is the representation? Here I can represent that line in the form of so different values. What I can write it? So I can write it, that is the K. I can write it the K. From P to K, I written the one vertical line. From this is known as the current, total current. From 0 to P, I am going to get that current I1. So input current, that is called input current. From P to K, I written the dropped the one line parallel with the voltage. So I am going to this value. This is a very, very important line. From this, you are going to do the remaining all things. Okay. So what is happened here? From P2, so output line, that what is the output line? AB is the output line. Okay. So now you can see here. Can I get the way? Okay, I can. Sorry. Now you can observe here. Now you can see the from P2, take the dark color, take the which color? So violet color. Okay. Now this is the P line. Okay, this is a P, and you return the one line is taken from this to, I can take this is a I1 current at an angle of phi load current at that condition. Okay. So now draw the one vertical line here up to this one. So represent this is a K. Okay. Now here you can say this is equal to M, and you can represent this is a N. Okay. Now this is represent, this is a J. So this is a line. Okay. Now based on this line, I can represent the values. So what is this value? Okay. Now here I can write it in the form of, now I can take this, I can remove this all things. Sorry. Okay, from this one. Okay, I can write it now. What is happened here from PM? Okay, so PM I can write it the output of the motor, output. Okay, PM length. So output of the length. Suppose if you have measured the PM length, for example, that may be 2.3 centimeters into current scale already you calculated. So previously you calculate what is the current scale, 1 centimeter is equal to 839. So previously we calculated. So 2.3 into 839.5 watts gives the, that is the, what is the output of the motor. Okay, whatever the power scale, here is the power scale, write it power scale. Okay, that is the PM. Now what is the value of, so here PK, so that is the PK from P to K, total length of the line, that is equal input line, input line. So how to know that value? Measure the length and convert into the power scale, then you know the input. If you know the output, if you know the input, so easily can calculate the what is the efficiency. Efficiency is equal output, okay, output by input. Okay, output by input, simply you know that. So that purpose I am going to get it. So output we know, input we know. What is the output? That is equal PM. Okay, what is the output here? So that is equal to PM. What is the input? PK into 100. So I am going to get is the percentage of efficiency. Simple. You know the distance, you know the distance, you converted the power scale, you are going to get efficiency. So that efficiency at that condition, at the load current, this I1 condition, this is the efficiency. Okay, now what is the power factor? This power factor is this one. Okay, so file you measure the with using the compass, then we are going to get that value. Okay, now I want the fixed losses. What is the fixed losses? Here the fixed losses are, I can take this one. Now the fixed loss is called, the fixed loss is equal to JK. Measure the length, convert it. I know the fixed losses. Then what is the M and N? What is the M, N? That is known as a rotor copper loss. What is that one? Rotor copper loss. Similarly, here what is that one? BE, that is equal BE. This is a rotor copper loss. This is a stator copper loss. Already we have seen. Similarly, Mn is the rotor copper losses and Nj is the stator copper loss. Okay, so that is equal to Mn is the rotor copper loss and Nj is equal to stator copper loss. Simply measure the length and you are going to get the value. Okay, this is enough. Now we know the efficiency, we know the what is the copper losses of rotor, what is the stator copper losses of rotor, what is the fixed losses by is the circle diagram. Now I want to know the full load slip. So what is the slip? So we know that based on the slip. So you already know the basic formulas, slip are required. Okay, what is the slip? So yes, slip is equal to, yes, I want to know the slip. Okay, so slip can be calculated in terms of power input. So what is the rotor input here? Rotor input, that is the torque line, that is equal P N. Where is the P? So this is the P. What is the N? Here. So that is equal rotor input. Okay, so rotor input, that is equal to, so what we are calculations P2, this is equal P2. Then what is the, I want to know the slip. So here the rotor copper loss is equal to S into P2. Okay, so I know the Pn length known, I know the rotor copper loss this length known, then I easily calculate the S. Okay, so what is the S? So, I can calculate S is equal to, okay, full load slip is equal to Mn by, okay, Mn by Pn. So, I can get this slip easily, okay, that is the thing. Now, suppose I want to know the speed, I want to know the rotor speed. If I know the slip, I can easily calculate that is, what is the relation? So, here the relation n rotor speed is equal to 1 minus s into ns. ns rated synchronous speed, s is the slip, you calculated from this one. Substituting this one, I am going to get the speed also. Okay. So, these are the things you have to remember, you have to practice it. Okay. Now, everything is calculated, full load power factor we calculated. So, what is the full load calculated and how to calculate it, already we know them. Full load efficiency we calculated, everything we calculate. Similarly, we can do the everything in this one. Now, up to this one we have seen previous classes. Now, I want to extend our circle diagram with the maximum output and maximum torque and maximum input. Okay. So, how to draw this maximum input? So, for this purpose, I am going to write it here. Okay. So, shall I write this one? Okay. Now, so this is the thing. So, this is the line to this one F. Okay. So, these are the line. Now, I want to draw the maximum output. So, maximum output. What is the output line? Here the A, B is the output line here. Okay, this is the output line. Draw a line parallel to the output line, okay, that is equal AB, tangent to the semicircle here. So, draw AB line tangent to here, tangent this one. So, from AB draw the tangent and it is touches on the circle. From that you draw the one parallel line with the this V. So, this is known as the maximum output line. Okay. So, that indicated by, so here going to the, that is known as a H, and here I can represent on the output line, that is equal to the I. Okay. Now, the H I is equal to maximum output line. How it run? Simply take the parallel line AB, that is the output line, and parallel to the AB line, and draw a line with tangent to the semicircle, and it touches at H. From H2 and drop the one line up to the output line, you are going to get the point I. Then length of HI indicates the maximum output of motor at that condition. Okay. So, what we have seen, draw a line parallel to the output line AB, tangent to the semicircle, it touches at H on semicircle, and they draw the vertical line up to the output line, which meets at I. Then HI represents the maximum output. Okay, it is clear. So, we can write that different way also. Okay, dear students, better to remember this. Just whatever the line, take the tangent to that parallel. Okay, this is one. Next, I want the maximum torque. Maximum torque. Similar to this one, where is the torque line here? A is the torque line. Okay, so take the AE line, parallel to this AE line, draw a tangent on semicircle. Okay, draw a parallel line with torque line AE tangent to the semicircle. Then, so you are going to get one point. So, where you are going to get that point? So, that point is nearly, so represent that thing. Now, you draw the one line. Okay, you take this is a take another color. Okay, so better to take this one. Okay, so here is the AE line, this is the output line. Okay, output line. From parallel, you take the one tangent to this one. So, what you are going to get? So, you are going to get the one line tangent this one. Okay, then draw a tangent line from this one. So, draw the one vertical up to the torque. Okay, this is known as the maximum torque line. So, where it is touched here, so you represent this touching line is equal to R. Okay, now it is touching at here is the T, and it touching at torque line is a S. Okay, or T S. This is a length. Okay, from this one, so I am going to calculate the, this is the maximum length. Okay, this is a maximum length. I can easily calculate the what is the maximum torque of this line. Okay, this is the maximum. Now, so maximum torque is equal to, what is the maximum torque? Here, the maximum torque is equal to, so you can remove this one. So, maximum torque, length, maximum torque is equal to, what is the distance? That is equal to RS. If you know the length RS, simply into power scale, you are going to get the what is the maximum torque of the machine. Suppose I want the slip at the maximum torque is occurred. So, RM, so SM. So, that is the at which slip at which the maximum torque may be occurred. That is called R is equal to X. Reactance value is equal to resistance value. At that condition, we are going to the maximum torque. Similarly, I want to know the here also. The slip at maximum torque is equal to, I am going to get, this is called TS, length of TS divided by length of RS. So, I am going to get it. Okay. So, these are the maximum torque. Now, after knowing the maximum torque, I can calculate the maximum input also. So, how you are going to calculate the maximum input? It occurs at height point of the semicircle, at the point. So, I want the maximum, another is the maximum. Okay, so maximum torque known. Now, in this case, I am going to know the another maximum input line I require. So, it occurs at height of the highest point of the semicircle at point V. So, here is the this length, this from this one. So, represent V, and this is the on x axis. Okay. So, that is a total when the tangent to the semicircle is a horizontal, that is we can write it is a maximum input. So, we can represent this is equal to W. Then total maximum input is equal V into W length indicates the maximum input to the motor. Okay. So, these are the points. If you know the length VW into power scale, we are going to get the what is the maximum input to the motor we can calculate it. Okay, these are the total circle diagram, theoretical total circle diagram. Okay, so dear students, don't confuse and don't panic. If you do the one problem, practical problem, so it is a very easy. Okay, so very easy. What you have seen, so whatever the values we have seen here, so do in the same manner in problems. Okay, so shall we do one problem? Okay, so we will go in PowerPoint. Same thing we can conclude here. Okay, so what is the conclusion here? So now we will conduct the no load test. Okay, so here we are going to conduct the no load test and blocked rotor test on this induction motor. Then we are going to get that what is the no load current, what is the no load voltage, what is the no load power. Okay, and from block rotor test I am going to do the ISC, VSC and WSC I know, and VI method I am going to get the R1. At the same time R2 also we can calculate it in rotor rheostat method. Okay, so let us assume we performed this test on this one. Okay, so based on this one, so I drawn this all things. Okay, so so what we have calculated from the diagram, we can find out OP. Where is the OP? O P point. This is a P point, the full load current. Okay, so the P point is the this one and this is the O point. So this red line indicates the full load current. Okay, now the full load slip. So what is the full load slip here? Rotor copper loss by rotor input, that is called Mn. So here the Mn, so from output line to torque line, that is a Mn, okay, divided by, so Pn. What is the P? This is a P, this is a N. So we are going to get the slip. Okay, now the full load angle. So angle easily calculated. This is the angle, full load angle. There is a, at that condition full load, what is the power factor. Okay, efficiency. So efficiency already you know that. So that is a PM. This is a from P to M. What is the, that is equal then PK. Total output by input. You are going to get the efficiency. Okay, so and maximum output. So what is the maximum output? So we drawn the one tangent with parallel to the output line. Where is the output line? That is equal, AB is the output line, parallel to the AB. It touches on semicircle at point H, and we drop the one line that is equal. So one line is equal, here is the H, this is the I. That length indicates the maximum output as maximum torque. And draw the one parallel line to the torque on this one semicircle. I am going to get the that length, that is equal, touched is the R, S is the maximum torque. Okay, full load torque, everything. So already we have seen. Now here, based on this basic knowledge, we will do one problem. Okay, so this is a test you are going to do in laboratory. Okay, this is a, for example, this is a S1, this is a S2 spring charges, and this is an induction motor connected from the panel board with the help of variac. Okay, so by changing the variac, we are going to give the rated voltage in first test, and by changing the rheostat and rated current in second test. Okay, and so based on this one, we are going to get the no load readings and block rotor readings. Okay, so we are just let us assume performed these experiments on a given motor. Okay, find the required parameters of a given 3-phase induction motor using circle diagram. Okay, let us assume we done this problem with the help of these diagrams. Okay, one problem is given here. What is this problem? Okay, so what is the time? Okay, so we will see in the next class better. Okay, so dear students, we will do this problem in the next lesson. Okay, so what we have seen, so we once again we have recalled how the circle diagram is drawn, and we have known that the full load current, full load slip, efficiency, maximum output, maximum torque, and so maximum full load torque and starting torque, and maximum slip at which it occurs. Okay, everything we have seen. Okay, so dear students, we will do this problem in the next class. Okay, charging also.